Right. Good day, viewers. I welcome back again to our channel, and I want to talk about this subject mathematics and a particular topic under mathematics, and is simple indices. Indices. So we're going to talk about indices today and mention about 10 laws that we will need to solve indices question, because we solve a lot of indices question throughout the week, and we need to understand these laws for you to start solving them. After today's lecture, you can even go on to solve any of these questions. So just apply this law and expect the best results. All right, first of all, what's indices? Indices is simply the power of a number. So if we have something like a to the power of b, the b is called the index. Why I say index is because in this case it is singular. The a is the base, so this is the base, and this is the index. But if we have something like a to the power of b plus c, this is a plural power. Because of that, we say it's indices, not the indices. Right? Okay, so have that in mind. And there are about 10 laws that guide all the mathematical operations involving powers of a number. For instance, the first thing that you need to know is that anytime you're having an operation in indices, and then you have something like this, a to the power of n multiplied by a to the power of n. What's our answer? What's our possible solution? First and foremost, the base here, they are equal. So what we do is we pick one base and we add the powers. Let's say, for instance, the base is a. The powers are n plus m. Take note that this only occurs because the two bases are linked together by multiplication. The second rule states that a to the power of n divided by a to the power of m equals to, in this case, we are going to pick one base and we will subtract the power because it is linked together by division. So we say a raised to the power n minus m. Alright. Now the next rule that I will tell you is the third rule. If you have something like, for instance, you have something like a to the power of half is the same thing as the square root of a. Take note of that. And this rule is very important because when you understand this rule, you go to solve many things. Indices. And this rule leads us to our next rule, rule number 4. That says that if you have something like a to the power of m all over n, what you do is you will take the root of the denominator and raise the whole thing to the power of the numerator. What do I mean by that? What we have here as the denominator is n, so we'll take the root of n, say n root of a raised to the power of what? M. Now, what do I mean by that? Example. Let me make it a little bit practical now. Example, we have something like this: 8 to the power of 2 all over 3. What we'll do here is we're going to take the cube root of 8, and anything we have will now multiply or raise whatever we have to the power of what? 2. What's the cube root of 8? 2, because 2 times 2 times 2 gives us 8. So 2 to the power of 2 is what? 4. Is that simple? Alright, now that we've established these first 4 rules, let us go ahead and establish the next 4 rules. So let's say, for instance, that we have something like, so the fifth rule states that a to the power of n all to the power of m. So what I did, the a to the power of n all raised to the power of m is the same thing as a to the power of n times m. So please take note of that. A to the power of n all to the power of n is the same thing as a to the power of n times m. And we also have something like 1 all over a is the same thing as a to the power of minus 1. Take note of that. 1 all over a equals to a to the power of minus 1. And we also have something like a all over b all to the power of n is the same thing as, see what I did here, a all over b all to the power of n is the same thing as, we can share the powers to each to each numbers, both in the numerator and the denominator. So you can say this can also be written as a to the power of n all over b to the power of what? N. Take note of that. Now we can go further to say that we also have this rule number 8, that a to the power of n all over b to the power of n. Remember that in our last law we said that a to the power of n or a all over b to the power of n can be shared. Now if it is shared, it can be collected as one power. So we can say something like a to the all over b all to the power of what? N. Just the inverse of the former rule that we discussed. Now we can also go further to say any number to the power of 0 is equals to what? 1. A very important rule. Any number to the power of 0 is equals to 1. And the last rule here says any number to the power of 1 equals to what? That particular number. So thanks for watching this video. The next part of this video, we'll talk about examples. We'll deal with, I think, about 20-30 examples concerning the indices. So stay tuned for the next video, the next part of the video. And thanks a lot for watching the video to the end. Subscribe and